stations, action stations. Assume NBCD state 1 Zulu. Action stations, action stations.
The drains are now open, don't move until the water's all gone.
Those scenes were from a training exercise inside Havoc, the Royal Navy's damage, repair, instructional unit. They show how warship crews can be exercised realistically under extremely stressful conditions to meet real emergencies if they happen. Emergencies at sea can bring about intense problems for damage repair teams. Unlike aircraft or land vehicles, the survival of vessels at sea can be very dependent on the repair action of the crew during an emergency. Various recent military and civil incidents have shown the importance of damage control, with the need for realistic training. In the Falklands, HMS Sheffield was hit by an Exocet missile and eventually sank, even though the damage repair teams had fought hard to extinguish the fire and save the ship. In the Gulf War, the USS Stark was damaged after a hit by an Exocet missile. In the North Sea, although Piper Alpha was lost, the fire was extinguished and the wellheads were capped. The Royal Navy's solution to this problem is to train its crews on the Damage Repair Instructional Unit, known as the DRIU. The DRIU was designed and manufactured for the Royal Navy by Vosper Thornycroft. This unit, called Havoc, is based at HMS Raleigh and has been in continuous use since 1987. The unit simulates 3 decks of a warship, which can be rolled, heeled, and experience simulated action damage. One deck is fitted with stanchions, guardrails, hydrants, a small davit, and 2 deck houses with enclosed ladders to 2 deck. Crews are trained on one deck under rolling conditions to use emergency fire pumps to drain compartments below. Two-deck includes a passageway connecting a number of compartments which are in the exercise area, the senior rates casualty handling area, the fire repair party post, the ventilation fan chamber, the first aid post, and the workshop. The instructional staff can view the exercise from the observation area. The control room has total control of the exercise environment. Three-deck includes the junior rates mess and the generator compartment where damage is simulated. Damage is simulated by punctured decks and bulkheads with water at a pressure of 0.4 bar. Splinter damage and distorted hatches form part of the exercise. Splits in high-pressure pipework operating at pressures of 8 bar. Non-toxic smoke introduced through the ventilation system. And action noise introduced through the public address system. Observation areas allow monitoring of 3-deck. Adjacent to the DRIU is the pump house, which provides the services to the rolling structure. It contains an overhead tank holding 100 tons of water for the training exercise. It also provides hydraulic pressure to the computer-controlled rams that give the DRIU its rolling motion. Now we have formed some idea of the capabilities of the DRIU, we will look in on an exercise of a Royal Navy crew.
Hands to action stations, hands to action stations. Assume MBCD state 1, condition Zulu.
The ship is closed up under air attack. The hull is rolling plus and minus 7 degrees.
Hands to action stations, hands to action stations. Assume MBCD state 1, condition Zulu.
Splinter damage has been sustained. A split high-pressure water pipe on 2-deck. Hold bulkheads in the junior rates mess. And in the generator compartment. The repair party on 2-deck are bypassing the high-pressure leak. The damaged section can now be isolated. Down below in the junior rates mess, the damage is being sealed using wooden wedges. Fire pumps are limiting the increase in flooding.
Team leader! Next stage on that. No. Utilise your team.
A power failure has extinguished the lighting on 3-deck. Efforts are continuing to contain the leak in the generator compartment. With lighting restored in the junior rates mess, the repair work continues. Smoke is now entering the compartment through the ventilation system due to action damage elsewhere in the DRIU. The bulkhead leak has been successfully contained with wooden wedges and the compartment pumped dry. Another hit has caused a high-pressure leak as well as deck leaks in the generator compartment. To contain this damage, bedding material is being used to effect the repair. The increased flooding makes it necessary to evacuate this compartment. This exercise is now complete. Motor-driven drain valves can empty each flooded compartment in approximately 1.5 minutes. The water is being drained to the sump below the DRIU, from where it will be pumped back to the header tank for the next exercise. After a collision in the Gulf whilst on escort duties, HMS Southampton was saved by a crew who had undergone training on the DRIU. Crews who have experienced the realistic and stressful conditions produced by the DRIU will be better equipped to deal with disastrous situations if they ever arise. The system forms an excellent investment for any naval force or organisation who may have to deal with fire, flood and smoke at sea.